Hey everyone, today we're going to build a production-ready serverless web application on AWS from scratch. We're going to be using Amazon S3 and CloudFront, as well as API Gateway and AWS Lambda for a scalable and serverless backend. And as usual, we're going to build this application with Docker and deploy everything with Terraform. So the goal is to deploy a dynamic web application without managing a single server. For the front end, we have a static website, which is basically an HTML file, and it's going to be hosted on S3 and delivered globally via CloudFront CDN. And for the backend, we have a serverless API gateway, which the front end can call to get dynamic data. So our simple app is going to load a static page, and then we're going to call our Lambda function via the API gateway to fetch a message and display it to the user. So let's walk through the architecture of this very simple project that we're going to be building. A user is going to navigate to our website. The request is going to hit Amazon CloudFront, and CloudFront is going to act as the global CDN and the front door to our application. It serves a static index.html file directly from the edge cache. If it's not cached, then it's going to go to the S3 origin and get the HTML file from there. So once the page loads on the user's browser, there's going to be a JavaScript function that makes a fetch request to the backend API. So the request to the backend API is also going through CloudFront to the API Gateway endpoint. API Gateway receives the request and triggers the Lambda function. Our Lambda function in this project is just a small piece of Python code that returns a response to the API call. And we're going to take a look at the Python code as well as the Terraform files in a second. So the response travels back the way it came, from Lambda to API Gateway to CloudFront, and then back to the user's browser. The front-end JavaScript then parses the JSON response and updates the web page to display the dynamic message. And that is the end-to-end serverless application that we're going to be building in this project. So let's take a closer look at what CloudFront is doing. So the default behavior is that any / request or a request going to index.html is going to be routed to the S3 bucket to serve the static content. Any requests going to the /API route is going to be directed to the API gateway. So this means that our browser is talking to one domain, the domain of the CloudFront distribution. It doesn't need to make a separate request to the API gateway. Now let's take a look at the project structure as well as the Terraform files that we're going to be using. As usual, I have a README file that you can follow for this project. Here's our project, CloudFront S3 Lambda API Gateway. Now I've already explained why we're using Docker and Terraform for this project. If you want a refresher on that, then you should check out the video I made about ETL, Glue, and Athena. So our Terraform files are sitting in these two folders, backend bootstrap and infra. So the main .tf file is basically where we deploy the backend S3 bucket and the DynamoDB table. In our infra folder, we have the resources that we're going to be deploying. So I'm just going to run through them very quickly. Here we have our API gateway Terraform file, which basically creates the API gateway, specify the cores, cross-origin resource sharing. This is going to allow our front end to make a request to the API. And then we have the API gateway integration. Basically, this enables us to connect the API gateway to the Lambda function. And here we specify the API gateway route, and it's basically a GET request to the /API route that we mentioned earlier. And then for the environment, we're just going with default. And environments are basically what enables you to distinguish between the different deployments of your application. You might have a deployment for your dev environment versus stage versus production environment. And lastly, we also need AWS Lambda permission, which basically allows the API gateway to talk to the Lambda function or to invoke the Lambda function. Now let's take a look at the CloudFront.terraform file. Now I've left extensive notes on this file, so I'm not going to be going very in-depth here, but I'm going to run through this quickly. So we're building our OAC here. The origin access control is basically, or the idea behind the origin access control is that we don't want any person or any resource to talk to the S3 bucket. we want to make sure that our S3 bucket is private, and the only resource that can talk to it is this specific CloudFront distribution. And then here we specify the CloudFront distribution, and we specify the origins. We have the S3 origin, and then we have our API gateway origin. It's going to be listening on port 80 as well as 443. Here we have two directives: ordered cache behavior and default cache behavior. So the ordered cache behavior is going to take precedence, and this is for the API gateway. And generally speaking, we don't really cache anything for the API gateway. So if you take a look at cache policy ID and origin request policy ID, these are basically AWS managed policies that allow us to basically not cache anything and basically forward everything to the API gateway, which is best practice. Now for the S3 bucket, we have the default cache behavior, and we specify the allowed methods as well as the cached methods. Both of them are going to be get and head. And then the origin is S3, of course. And the viewer protocol policy, this basically tells CloudFront to redirect everything to HTTPS so that the requests can be more secure. And the policy ID is this AWS managed policy. It's a policy that is designed for static content, caching responses, and it doesn't forward cookies or query strings. So this is a standard policy that you should probably go with if this is your first time. And then the default root object is the index.html file that we have over here. This is basically what our S3 bucket is going to store. This simple HTML file that our users are going to interact with from the browser. And in this file, there is a JavaScript function that is going to make a request to the API gateway, and it's going to use the /API route. And here we have the SSL and TLS certificate for this distribution since we're using HTTPS. And we are turning off the geo restriction because this is a very simple project. So let's take a look at the lambda.terraform file. Here we have the IAM role and the IAM policy attachment. Basically, our Lambda function needs permissions in order to run. And the permission that we're giving it is the AWS Lambda basic execution role. So here we're going to package the Lambda function, the Python code for the Lambda function. And that Python code is sitting here. As I mentioned before, it returns a very simple message, hello from Python Lambda. And here we have the actual Lambda function with all the specifications that we mentioned earlier, like the IAM role and the file name. A hash is going to be used. Basically, it's going to keep track of the Python file. If anything changes, it's going to redeploy the Lambda function to reflect the changes in the Python file. And lastly, we have our s3.tf file. We're deploying our S3 bucket. And here we're going to block public access to this S3 bucket. As we mentioned earlier, the only resource we want to access this bucket is the OAC. And here we actually specify the permission that we're giving the OAC. It's the S3 get object permission, and it's cloudfront.aws.com. That's the principal or the basically the resource that is allowed to communicate with this S3 bucket. And specifically, it's going to be our CloudFront distribution that we're deploying in this project. And here we specify the actual S3 object. It's the index.html file over here. And that's what this path is pointing to. And we use this e tag to also keep track of any changes in the HTML template. So now we're back to the README, and we're actually going to build this project. Now I've already started on the first couple of steps, so it shouldn't be a problem. We're just going to run make build, make shell. This is basically going to build your Docker image and spin up the container. It's going to drop you inside of the container. And then this is what we use to initialize and deploy the backend resources, our S3 bucket and DynamoDB table. So that's as far as I've gotten so far. And let me show you what we have. Okay, so as you can see, we have the S3 backend. Let's take a look at the DynamoDB table, refresh the page, and then we have our DynamoDB table. Now we're going to actually deploy the infrastructure. So we're going to run this Terraform init command. This is going to take a second. Now let's run Terraform plan. and then Terraform apply. Okay, it looks like everything was deployed. So let's go to the AWS console and take a look at our resources. So our S3 bucket for the front end is there. And we have our index.html. And the CloudFront distribution has been created. We click on origins, and then we can see our S3 origin and our API gateway origin. And both of them have domains. So our API gateway has been created as well. We have our GET request, and the Lambda function has been created. And here's our simple code for the Lambda function. Okay, now we're going to validate and see if our application is working as expected. So let's copy these commands. We're going to get the CloudFront URL. Then we're going to make a curl request to it. Okay, so let's copy the curl command. And paste the CloudFront URL. Okay, so it's a cache miss. Let's try that again. All right, cache miss. Let's do it again. Okay, it's a cache hit. So now it's retrieving that HTML file from the cache, which is a good thing. We can also validate this on the browser using the same URL. So we're going to copy this, open up the browser. It says it's a cache miss. So let's refresh a couple of times. Okay, cache hit. Okay, now let's validate the API gateway. Let's get the URL of the API gateway, copy it into the curl command. Okay, looks like the API gateway is indeed invoking the Lambda function, and the Lambda function is returning the expected message. So that shows us that the API gateway and the Lambda function are working. But we're going to need to use the browser to validate that the requests to the API gateway are going through CloudFront as well. Okay, back on the browser, let's click on the Call API button. Then as you can see, this popped up here. And as you can see, we're using the CloudFront URL, and it's going to /API, and it returns the expected output from the Lambda function. So we know that it's working from the browser as well. Okay, that concludes this project. If you enjoyed this video, please give it a thumbs up. Make sure you follow the cleanup section of the README to avoid any unwanted costs. And I'll see you next time.